I'm going to tell you a few words about Marco. He has been in this .NET universe since the early beta. This is something that I found really, really impressive, having him on board right now with us with such vast experience. I cannot imagine how much knowledge you can gain from actually seeing this framework and this universe build up in your professional lifetime. I think it's amazing. So this is something that I was really impressed with. He's currently based in London. He's working as a solution architect and focusing on cloud transformation. He has also been allocated as a Microsoft MVP for the last 10 years. So this is, again, really, really impressive. Everything all right? Up and running? Yeah, okay.
Thank you for the intro.
Enjoy.
Thank you. Cool. Hello, guys. Good morning. How are you? Yeah, it was a great talk, the one before. So my name is Marco. I'll be your host for the next hour or so. And we're going to talk about some very, very cool stuff. So ASP.NET Core, containers, Kubernetes. So it's going to be cool. How many of you, just by a chance, have had the chance to play with Docker, at least run it once? OK. Don't worry, the other guys. I'll take the talk from the very basics, so you will be able to follow it. So my name is Marco. I've been working with web applications for the last almost 20 years. And I've been a Microsoft MVP for 10 years. When I was first awarded, the expertise was ASP.NET and IIS. Now it's Visual Studio and Development Technologies, which sounds awesome, very, very vast and big. But I'm still very, very focused on anything that is web-related. So what is the topic for today? We're going to talk about the basics of Docker, why we should care about Docker. Perhaps we are developers, why we should investigate a technology which is actually smelling a lot of DevOps stuff. And we're going to see what are the functionalities that allow us to run ASP.NET Core applications in Docker. So this will take pretty much 10 minutes of my presentation. Probably I'll try to cut it short because I have a very little time. And the rest of the talk will be dedicated to porting a non-trivial application to Docker and then deploying it to Kubernetes in Azure. All right? Sounds cool? Great. So let's set some context first. So how did we get here? When I started working on IT, we used to have all these web server, application server, database server, so all distinct machines. And the main reason why we had that was isolation. We wanted to keep our applications isolated, so upgrading one application didn't jeopardize the stability of the other ones. And in that sense, the advent of virtual machines has represented a great breakthrough in terms of technology. Why? Because for the first time, we could take all these hardwares, which were very inefficiently used, and deploy many applications at the same time, just because we could simulate those machines. All right? Now, what is wrong with this model, which, by the way, is very valid even nowadays? I mean, most of Azure works on virtual machines. Well, it's that part, the operating system. Since virtual machines simulate the hardware, we have to install the operating system, pay for the licenses. That operating system will consume our disk space, memory, CPU, and so it's a big burden. So how do containers change the game in that sense? Well, because with containers, we have something that is very similar to a virtual machine. So it's something you can stop, you can start like a virtual machine, but it's very, very lightweight. You don't have the operating system. They run on top of something called container engine. And how's that possible? Well, it is possible because if virtual machines virtualize the hardware, containers virtualize the operating system. Or better say that they virtualize the kernel of the operating system. Now, this has a profound implication. First of all, our containers will obviously run in an isolated space. They will have their own process tree, their own memory, network stack, and things like that. But at the same time, we need to make a choice up front. We need to understand which operating system we want to virtualize. And this is basically what you are saying when you mention Windows containers or Linux containers. This is basically the operating system that you're making virtual. How does the container workflow works? So at the top of the stack, there's this concept of an image. What is an image? You can think about an image like the template of your virtual machines, or if you are developers, you can think about it like it was a class. All right, you write your class, and it's basically the definition of what you're going to use, and then you have a client, which is, for example, the Docker CLI, that talks to a Docker engine, all right? And this Docker engine, when I set that I want to run a particular image, will automatically download that image from the internet or from the local cache and transform it in a container, which is the running instance of an image. So it's like when you, in C# create an instance of the class before using it, all right? And we will see that this parallelism between classes and images is not completely out of context here, because there's a sort of inheritance with images as well. Docker, in terms of the engine, is open source. It's been open sourced for probably the last 6 years by the Docker Incorporated, the company. And it's free to use in its community edition. You can use it in production. It's very, very stable, and it's basically the de facto standard to run container-based applications nowadays. There is also an enterprise edition that adds some services on top of it, but we're not going to cover it during this talk. Cool. So, enough talking. Let's see it in action. So, as I said, Docker is mainly a client-server tool. So if I install, sorry, I need to enlarge this a bit. When I install Docker in my machine, I have basically two components. One is the Docker client. So there's this command line tool, Docker. Can you see it from behind? Or probably, great. And I can do, for example, Docker version. And as you can see here, I have my client, which is running on Windows, and there is a Docker server, which is a daemon running on the background, which is running on Linux. How the heck is that possible? This is a Windows machine. Well, it is possible because one thing that Docker installs automatically in your laptop is a very, very lightweight virtual machine that allows you to run Linux images on your Windows machine pretty much seamlessly. Okay, you don't even notice it. However, the most interesting part of Docker, it's not sitting on my machine. It's a website, actually, called Docker Hub. So if I go to the website, hub.docker.com, and I click Explore, this is a sort of think about it, like the App Store for us developers. All right? So you can go there. There are tons of images. Some of them are official. Some of them are open source of people who have made them available to the community. So say that, for example, I want to run WordPress on my machine. All right? I don't have PHP installed. I don't have anything. I haven't configured the IIS. But I can go here and just type Docker run WordPress. All right? And let me also specify this parameter. So WordPress is a website. It's exposed on port 80. I want to remap it to port 8080 on my machine. So this is the syntax. I hit Enter, and it says, OK, I'm unable to find the WordPress image locally. Now, an image is a collection of immutable layers. Some of these layers already happen to be on my machine for some other reason, because they are shared with other images, so I don't have to download them. Docker automatically downloads the other layers, and at this point, I have WordPress running. So I can go to HTTP localhost 8080, and here's WordPress, right? I can do Docker PS, and as you can see, there is a container called Bold Blackburn. These are randomly generated, and sometimes are really funny, which is running the WordPress image. And I can do Docker stop and pass the first few bits of the container ID that you see here. And now, the WordPress is stopped. So if I refresh this page, I will get an error. I can do Docker start, and now WordPress is back online. So you see how fast it is to start and stop containers compared to normal virtual machines, because obviously we don't have an operating system to boot here, right? So the operating system is just there. We just create a namespace over it. Now, if I do Docker rm, and since the container is in execution, I have to force this of the same ID. I'm going to remove this container. So the container is not there anymore. It's not running. It's not consuming my resources. But if I do Docker images, I still have my WordPress image here. So next time I want to run it, I just do a Docker run like before, but I don't have to download that image again from the internet. So this is the concept behind Docker, all right? Now, let's go to the very core of our talk, which is porting an application to Docker. Why do we want to do that? Because I want you to be able to do Docker run, my application, and it just runs without having to care about, oh, this is .NET Core 3.0. I actually have the SDK for .NET Core 2.2, so I need to upgrade this, all right? It just works pretty much like WordPress. So what is the application that we're going to work with today? Oops. Wrong icon. So it's very simple. It's a manager for a list of people. I can create a person, I can remove it, delete it, edit, things like that. But internally, it's something like this. It's not the typical Hello World. It's not super complex, but the concepts that we will see are applicable also to systems with dozens of microservices. So it's basically a front-end application, ASP.NET MVC. I didn't port it to, haven't ported it to 3.0 yet. It's still 2.2, sorry about that, which talks to a backend made in Web API, all right? The front end works with Redis, all right, as a distributed cache, and the backend uses MongoDB. Now, the first thing that we want to do, we want to be able to run it locally. And funny story, there is no way you can install Redis on a Windows machine. There isn't an installer for Windows for Redis. It just runs on Linux. So this is already something that starts to smell very interesting. So how can we run it? So let's go to Visual Studio and have a look at what we have. So I already have my solution. So there's the back end, there's the front end back here, down here. And if you look at the back end, for example, the backend is just using the normal MongoDB client SDK, right? And same for the front end, in which here in the startup, I've configured a distributed cache provider that uses Redis, right? So I'm not doing anything special here. So first step, let's port all of this to Docker. So what does it mean, porting it to Docker? It means creating an image out of my application. I can easily do it in Visual Studio by using this option here, add, and I have a couple of things I can choose from. Either Docker support. This is useful when I want to run my single project in isolation within Docker, all right? Or I have container orchestrator support, which is the option we're going to pick. And this one is for when we want to run multiple projects at the same time, which is exactly the case of this solution. And here I can get to choose between multiple orchestrators. So I'm going to pick Docker Compose. And since this is .NET Core, I need to choose which image we want to create, a Linux container or a Windows container. And I'm going to pick Linux containers because they are generally faster and more lightweight than Windows ones. Now, as soon as I've done it, Visual Studio does his stuff. Let me do it also for the front end here. So add container orchestrator support, select Docker Compose, click OK, select Linux. So what has Visual Studio done now? So first of all, it has created a file called Dockerfile in each of the projects. What is the Dockerfile? The Dockerfile is a set of instructions to create an image out of my project. Now, we're going to get deeper on that in a few minutes, so don't get confused by all these statements, but let's focus only on the first line, which says from Microsoft.com.NET Core ASP.NET 2.2, blah, blah, blah. What is that? So this is to say that we are creating an image based on that image, all right, which is the official runtime for ASP.NET Core 2.2. This is the concept of inheritance I was mentioning before, all right? And the other thing that Visual Studio has done is that if I do a Docker PS, now, as you can see, there are already 2 containers running for my solution, back-end and front-end, okay? So I'm like, okay, this is interesting. Let's press F5 and see what happens, right? So I've pressed F5. Hopefully, did I? Yeah, it's compiling. I pressed F5. Visual Studio is running as expected, as I would expect as a developer. Containers are there. The front end is exposed on port 32768. Let me copy this. Oh, wow, my application is running. Cool, I go to About, and as soon as I go there, I've set a breakpoint, and that breakpoint is being hit. Now, this looks trivial, but it's not, because this is actually running inside a container. If I press, so I can do my variables inspection, all the things, but as you can see, the operating system is Unix, right? So Visual Studio automatically created a container, installed the remote debugger into that container, and it's connecting to that remote debugger to allow me to do a debugging like I would expect as a developer, even though the application is running in a container. Let me do another experiment. So when I develop web applications, I usually, for the front end, I used to go here, change some stuff. So for example, it can run anywhere, even in Docker. All right, I save this. And without recompiling, I go back to my home page, and I normally would expect to see my changes. And they're there. And this is another non-trivial thing, because if you think about the workflow we mentioned before, you would need to normally rebuild an image, recompile, and that takes time. However, we don't need that. And why is that? Because Visual Studio is sharing our solution folder with the container in real time, so that any changes that we make are immediately reflected into the container without needing to rebuild it. All right? So this is the very first important thing we've taken out of this session. So as a developer, my development experience is barely modified, even though I'm doing something completely different than I was doing before, all right? So I can keep doing the same things I was doing, and they just work. And this is quite cool. But our application is still lacking Mongo and Redis, so we need to to sort them out before being able to run the entire thing. So how can we do it? I could do a bunch of Docker runs, similar to the WordPress ones that we've seen before. But I want to point your attention to, oh, wow. To point your attention to another thing that Visual Studio has modified in my solution, which is adding this Docker Compose project. What is that? So this is a project that contains a file that describes my entire system, all right? And for now, there's only the back end and the front end. But I can go here and say, OK, you know what? I need a Compose demo DB, which I don't need to build. And the image will be Mongo. There is an official image for MongoDB in the Docker Hub that we've seen before, which is called Mongo. And I can do a similar thing for Redis. Compose demo, Redis, image, Redis. That's it. How do I connect to these guys? Well, one thing that Docker Compose guarantees me is that it will run a sort of software DNS, and the host name of Redis will be exactly the name that I've set here. All right? And same for Mongo. So I can go here in my app settings where I have my connection string to Mongo and just type compose demo DB. Right? And I can do the same thing here in the app setting for the front end. So Redis will be compose demo Redis. And instead of localhost, whatever the port, I can just type backend. Okay? Because backend is this. Now, I'll tell you the truth. I'm very, very tempted to press F5 and see if it works. But I want to do one last step before I do it, which is, if you recall the diagram, which is adding Nginx. So we've done it, all right, in half an hour. That's good. So how do I add the Nginx? I can't just add Nginx like a normal image, because I need to also write some configuration for it. I need to configure it to configure its routing to point to my application. So what I'm going to do is I'm going to create a custom service called web server, all right, which will work with a custom image called the web server, which I'm going to build live every time I push Control F5. All right, and this time the Docker file will be nginx/Docker file. What the heck is a nginx/Docker file? It's basically this super simple file there. So inheriting from nginx, I'm just copying a configuration file in a folder within the container where nginx expects to find the configuration. And this configuration is also quite simple. So listen to port 80. Any calls that you receive, you go to front end. That's it. All right? So let's go back to my Docker Compose. I can add some additional properties here. So for example, I can set that this one depends on front end. So Docker will not start it up until the front end is available. And this is because otherwise Nginx might flag that root as unavailable and return me a 502. So it's important to sort the dependencies out. And I can also say ports. I'm done with these randomly generated ports. I just want to expose port 80 of Nginx on my port 8080 on my machine. All right? So now I can do Control F5. And let's see what happens. So the first time it takes a bit longer. It will take some seconds. Let's go here on the console and type docker ps and see what's happening. So it's now still building the web server. But as you can see, I already have some containers running Mongo and Redis. All right? So I'm getting very positive that hopefully it will work. Let's go to port 8080 and to /people. And wow, I can create a person It's there. I can delete it. It works. It just works. And I'm not cheating, I swear, because if I go here and, for example, do a Docker stop of, yeah, sorry, the line carriage is awful. I get you, but bear with me on that. So this is Redis. This is the idea of Redis. I do a Docker stop of 3F6. Docker stop 3F6. I stop the Redis. I refresh this page, and I get an error because I can't connect to Redis anymore. I restart it, and my application is back online. OK? So Control F5, everything runs. Now, this is, to me, is incredibly cool, because think about what happens when a new developer joins our team. All right? Normally speaking, I don't know what your experience is, but my experience is that it takes 1 week for him to just download all the things that he needs just to build the application. All right? Here, we have a file that goes under source control. It goes on Git, that someone can download. It's part of the solution. Control F5, Docker will automatically pull all the dependencies, either from Docker Hub or from our private registry, a private repository of images of our company, and it just works. This is incredibly cool compared to what we were used to. So who thinks that this is cool? OK, a good percentage. Awesome. OK, great. Now, we have our images here. So if I do a Docker images, I can see that I have my, they're here on the top. I have my web server, front end, back end. So am I ready to distribute them? Well, actually not. They are marked as dev for a reason. These images actually are empty shells. They only work when there's a source code in the host machine that runs them. And this is because of the edit and continue thing that we just saw in Visual Studio when I modified the index.ch.html, and it was just reflected on the website. So these images are for development purposes. They need Visual Studio to run. They're not distributable. So how do we make them distributable? It's super simple. We just have to go back to Visual Studio, select Release here, and build our application. That's it. All right? Now, this will take some time, like a couple of minutes the first time you run it. So it's a good moment to go back on here to the slides and try to understand what that big Docker file that we saw before is about, because this is basically what is going to run now that we're building in release mode. So this is the Docker file that we've seen in Visual Studio, that Visual Studio has added to our application. And think about this box as my host machine, all right, in which I have my solution, my backend entities, the projects, the files, the C# files, and things like that. So we've already seen that with the first 3 lines, we are basically creating an image that inherits from the runtime and exposes port 80. Now, this is interesting because that image is only 270 megabytes big, all right? So it's, since we are basically distributing images over the internet, it's paramount that we keep those images as small as possible. And this one is quite small, all right? The problem is that it doesn't contain all the dependencies to build my code. So here, Visual Studio is creating this very complex Docker file to leverage a functionality of Docker called a multi-staged build, which is basically can be translated into, I just use a bunch of images, and at the end of it, you will get something that we will see in a moment. So here, 4th line, Visual Studio is creating another image called build, which is inheriting from the SDK. So this is the entire .NET Core SDK. It's almost 2 gigabytes. And after creating a source file on it, it's basically copying all my projects onto onto that source folder, sorry. And then it runs .NET restore, which means just download all the NuGet dependencies of this project. All right? Then it performs a copy dot statement. What does it mean? So the first dot is the first parameter is my machine. All right? So it's copying all this is recursive, so it's copying all the files in the current folder, which is the solution folder, onto the dot of the container. So it's the current folder of the container. So basically, it's copying my entire source code onto that container. All right? And then it's running a .NET build in release mode, outputting the DLLs onto the /app folder. Next step, it creates a new image called publish that inherits from build this time, okay? So it contains everything that we built so far into the build image. And then it runs a .NET publish release into the /app folder. So if any of you have ever done in your career a publish of a project, you know that this one will basically output all the DLLs that you need in order to run your application into that local folder, right? And it will also minify your, precompile your Razor pages, minify your JavaScript and CSS files. So at the end of the day, here in /app, we're going to have all the things that we need for our application. Fourth step, Visual Studio creates another image called final. And this one inherits from the base image, the small one. And it copies all the content of the /app folder of the publish image onto a /app folder of this final image. Last statement is what happens when you do Docker run. So you basically set that as the entry point. So when you do Docker run, just do .NET backend DLL, okay? Which, if you have ever developed a website in ASP.NET Core, means that it starts Kestrel and the application starts up, basically. All right? And this is basically the final image that we obtain out of this super complicated Docker file, which is not actually that complicated if you think about it. It's very, very linear. So by now, Visual Studio should have completed this job. So if I do Docker images now, let me do it in a separate, so I don't have problems with scrolling. As you can see now, I have my backend and frontend marked as latest. So this is the tag which is conventionally used by Docker to say, OK, this is the latest version of backend and frontend. And these are distributable. So you can do Docker run that frontend. And if you have access to the repository where that image is stored, it will just work, right? So we're ready to distribute them. How do we do that? Well, first option that we have is deploying it to Docker Hub, like Redis, Mongo, WordPress that we've seen so far. And as free users, you're entitled to unlimited public images that you can store there, and unlimited public images and one private image. All right? The other option is using some private registry, which is probably the option that we would prefer if we're developing for an enterprise. And if you are in Azure, one good solution for this is using an Azure Container Registry, okay, which is a service in Azure that is basically a container registry like Docker Hub that is private to your organization, all right? Why is it that an interesting option? First of all, because it's friggin' cheap. It's very, very cheap. The second is that it's integrated with the Azure Active Directory, so you can configure in Azure Active Directory who has access to that registry, who can download images, who can push images. So security-wise, it integrates nicely with the security infrastructure of our organization. The third thing is that like any other service in Azure, well, most of the services in Azure, it can be geo-replicated. So if your application is running with service in multiple regions, you can replicate automatically that container registry onto the same regions so that your downloads will be freaking fast because they happen within the same data center, all right? So this is fully compatible with Docker. There's a lot of documentation on how to push images to Docker Container Registry. However, as a developer, I would expect that once I've done my changes, I do a git commit, git push, and my code goes to a repository, perhaps in Azure DevOps. That code gets built, and it creates an image that is automatically pushed here in this container. So how do we do that? Well, it's quite simple, actually. It's way more simple. It's probably the simplest pipeline you've ever built, all right? So here it is, just 2 steps, all right? So I'm using a Docker task, which is by default present in Azure DevOps, all right? Which is basically wrapped around the Docker CLI, the command line interface that I've been using for the last 45 minutes. And as a first step, here I have a build, all right? So here I'm setting that I want to build an image, and I'm using the same Docker file that we've seen before, that Visual Studio has created. And that will contain the entire SDK and all the dependencies described, all right? And the second step will be, oops, sorry. The second step will be to push that image onto my Docker registry. And here, as you can see, I have configured my Docker registry here in Azure DevOps, so I don't have to care about assigning permission to the service principal, storing the keys. So like any other thing that you do in Azure, Azure DevOps is very nicely integrated and can provision a service principal for you automatically. The other thing I wanted to highlight is this. So basically here I'm creating an image called backend, all right? And I'm assigning a tag, which is the build ID. And this is interesting because the build ID changes every time I run a build, so I can keep a history of all the images that I've built so far. Bottom line, if I run this build and I go here on container registry and I look at the repositories, I will have my backend, for example, with all the versions that I've built in the past. Okay, I get it's not very semantic. We can improve that, but it's a good start. So I have all of them, and I can just pick the one I want to deploy, and perhaps click on this ellipsis and say, run it as a container instance, or deploy it to a web app. Now, question for you. Do we really want to do that? Think about having 12 microservices. For each of them, you do deploy to web app. It's not really the best solution. I would like to have something which is pretty much like what we did with Docker Compose. So something that describes the entire system and allows me to run it as a one single thing. So we need something more than just Docker. We need an orchestrator. So what is an orchestrator? Well, an orchestrator is a software that allows me to describe a system and takes care of running it over time and keep it healthy, right? And Kubernetes is probably the most widely used orchestrator out there. Kubernetes is a software made by Google. It shares the DNA with 2 other orchestrators called Borg and Omega, which Google has been running for the last 12 years, I think. So if you happen to use Gmail in the past 12 years, probably you've been served by one of these 2 guys. It's free to use. It has been released to the community and has one of the most impressive open source communities out there. So you go on GitHub, you see that there's a roadmap, a lot of responsiveness on issues and things like that, because it's officially supported by this huge community of developers. What is practically speaking? Well, it's a cluster of virtual machines called agent nodes that can run a workload expressed in terms of containers. So each of these worker nodes can run some containers, or let's call them pods, like Kubernetes calls them. Now, a pod is not actually the same thing as a container, but for the sake of this talk, let's assume that they are exactly the same thing, all right? Don't say it out of this box, because people will run after me, but let's imagine that they are exactly the same thing. How do I deploy these pods to this cluster of virtual machines? I don't do it directly. I don't say, OK, pod A goes to virtual machine 1, but I talk to a special node called master node. And this master node, I can talk to it with a command line interface similar to the Docker CLI. This is called the kubectl or kubectl, right? And so the idea is that I assign a workload to this master node, and the master node will know the topology of the cluster, will deploy these containers onto the available nodes, and if a node dies, it will move those containers elsewhere, basically. So this is the general concept of an orchestrator. Sounds cool. There is one problem. Kubernetes, like anything that Google makes, is freaking complicated. All right? I don't know how many of you have had an experience of managing a Kubernetes cluster. How is the update experience? Cordoning the nodes. Yeah, but exactly. So the good news is that in Azure, there is a service called Azure Kubernetes Service, or AKS, which allows me to go here, do create a resource, I select Kubernetes service, I set a bunch of parameters here in the usual Azure way, and 5 minutes of time, your Kubernetes cluster is alive and kicking, right? And so I've created one for you already, which is this one. And for example, if you want to upgrade it, you go here, you select the version where you want to which you want to upgrade it, and it just does everything automatically. All right? You need to scale your cluster, spin up more virtual machines. You do it the Azure way. Boom, slider, and you have it. All right? So it's amazing. I can see that you're liking it. Okay, cool. So how do we deploy code to Kubernetes? We use something which is a manifest file, like this one here. Let me open it. Where is it? Yeah, this one. Let me zoom this in a bit, remove this stuff. Now, it looks complicated. For some aspects, it might be. But as you can see, we have some old good friends here. So there's my backend. There's my front end as well, and my web server. All right. What you don't see are MongoDB and Redis. Why is that? Well, let's think about what we're doing here. So you can run Mongo in Kubernetes. If you go to the documentation, there's an entire page on how to run MongoDB in Kubernetes as a container. It's supported. There are a number of things that you can do. But think about go out there and try to hire a MongoDB DBA who knows about Kubernetes. Good luck with that. All right? So since we're in Azure, instead of looking for unicorns, probably we might want to leverage some platform as a service, some of the PaaS offering that we have in Azure, and perhaps replace our Redis and Mongo that we were using in dev with, in my laptop, with Azure Redis Cache and Azure Cosmos DB, for example. All right? So this is the next step to run everything on on Azure. So how do we do that? I have created a release pipeline which, well, it's quite interesting because I'm trying to implement a one-click deployment here. So ideally, what I want is a release pipeline. I click a button, it creates Redis and Mongo, it grabs the connection strings, stores them in Kubernetes, and deploys my serverless part, my stateless part in my backend and frontend into Kubernetes. So what I've done here is creating a pipeline that has my frontend, backend, the web server as an artifact, plus a set of provisioning scripts. All the code is in GitHub. I'll leave you the link after the presentation, so you can play with it. The interesting thing is that when I do create release here, I can, since I've stored, I used the tag of the build ID as the tag of the image. I can select which build ID I want to use, which will be an image with that tag in my Azure Container Registry. All right, so I can deploy the new version of the front end. Wow, crap, it doesn't work. Can roll back to the previous version. So you can do also that stuff. So that's why it's important to keep all the images created as distinct pieces. And we've seen that Docker tends to reuse layers if they coincide. So the occupancy in my registry will not be as big as duplicating all those images every time. So I can create a release here. Let me do it. And this will basically run. And what does it do? Well, let's have a look at the content here. So it's not that complicated. The first three steps are to basically, the two steps are to provision my, to create automatically my Redis cache and Cosmos DB instances. So I'm not going to delve deep on that. The important point is that out of these provisioning scripts, I will end up generating a couple of connection strings that I'm storing in a variable during this pipeline, and I'm referencing this variable into my create secrets stuff, which is using this manifest here, provisioned secrets.yaml. And if we look at that, I'm basically saying, yeah, this is create a secret code. This is pretty much like the key vault in Kubernetes. Okay, it's a secure place where to store things such as passwords or connection strings. And here I'm creating a secret called, for example, AKS demo Cosmos that contains the connection string to Cosmos DB. And again, you can have a look at the PowerShell scripts on how to output that variable so that it can be replaced here. The important bits are, by the way, in the file that we saw before. And in the meantime that everything gets deployed, it's probably important to try to understand a bit more of this. So let's go back to the slides, and let's have a glimpse on the Kubernetes object model. So it looks complicated, but it's really quite simple. So at the bottom. Oops. Come on. Oh, I spoiled you the solution. At the bottom part, I'm basically defining how my pod looks like. So here I'm saying, OK, create a pod called frontend that uses the latest, for example, the latest image of my frontend image, and expose it in port 80. Right? This will create a running container on my cluster, all right, that has its own network identity. However, I'm not creating it directly. I'm doing it within an object at a higher level of abstraction, right, called the replica set. And the replica set is basically something that allows me to duplicate, to multiply the number of pods I want to create. So for example, my front end, I expect a lot of traffic. I want 3 instances of my front end running on my cluster. Now, the replica set does 2 things. First of all, it obviously creates 3 instances of the front end. The second thing is that it spins up a background process that constantly monitors the availability of these pods. So if the actual number of instances is equal to the number of instances I've specified there, the world is a happy place. But the moment a pod crashes, the replica set will automatically spin up a new one, all right, so that my application stays healthy over time. I'm not creating a replica set directly. I'm doing it within another object called deployment that allows me to do roll updates. So I can basically deploy version 2. If I don't like it, I can easily roll back to version 1. I can control how version 2 gradually replaces the version 1 pods, so I can do a number of things which are probably too advanced for this talk. Now, with that fragment, I have 3 pods running, each of them with its own network identity. So you see different IPs. How do I refer to them? How do I call the front end? I need another object called service. And what is a service is basically a sort of a software DNS, all right? So by which I can associate a host name, in this case front-end service, to a selector. If you can see, I'm setting a selector to app front-end, and this is exactly the same label I've set here on the replica set. All right? So basically what happens is that it will create a load balancer over my 3 pods identified by that selector. And that load balancer is an intelligent load balancer. So think about the example I was giving before. A pod crashes, that will automatically be removed from the load balancer so that we don't risk that incoming traffic hits it. Right? Now, Kubernetes should have deployed everything by now. If I go here and I connect to my cluster, I do, for example, kubectl get nodes. I can see that my cluster is up and running. There are 3 agents available, 3 virtual machines. If I do kubectl get namespaces, I can see that there is a staging namespace. One thing that I didn't highlight is that in this file, I'm deploying everything into a namespace, which is my environment. All right, so I can have multiple environments of the same thing coexisting into the same cluster, pretty much seamlessly. And if I look at what's in that namespace, so for example, I do get services in the namespace called staging, I can see that there is a service. There are a few services, the backend and the front end, because the front end needs to talk to the backend as well, so you need a service for that. And there's a web server. The web server is an Nginx, and I want it to be publicly available. So as you can see, I've configured it as a load balancer. It's all in that manifest file. You can have a look at that later. I've configured it as a load balancer, and that will instruct Kubernetes to spin up a public IP in Azure and wire it up to that service. Whereas the other ones are just cluster IPs, and they're not publicly available. I don't want someone to be able to connect directly from the outside to my backend. And in this way, it's only accessible from within the cluster. How much time do I have? It's over. So, 2 important things. First of all, if I go to this IP, /people, yeah, my application is running. This is my application running in Kubernetes, integrated with Azure Redis Cache and Cosmos DB. And it even works, all right? Which is a good thing. The other important aspect is that if I want to monitor what's going on into my cluster, Kubernetes comes with a handy tool called dashboard. So I can do Obviously, the dashboard will allow me to see inside my cluster. I don't want it. It's another thing that needs to be protected from the internet. So in order to access that dashboard, I need to use this, this command here, Kubernetes kubectl proxy, that will create a tunnel between my machine and my Kubernetes cluster running in Azure, all right? So, which means that I can go here, I can go to this nasty URL. This is not actually hitting my localhost, all right, okay? This is running in Kubernetes in Azure, okay? My localhost is just a proxy by which I can reach it, because otherwise it's not available in the internet. And here, I can see that, for example, oh, wow, I have my staging namespace. I can see which deployments I have, which pods are running there. I can go here into this pod, and I can even see the logs of this pod. All right? This is quite cool. And you know what I can do? I can go here and say, I want to delete it. And as soon as I delete it, I go back to the list of pods. And as you can see, there's another pod, which is a container creating. And should be already there if I refresh the page. It's usually super fast. Yeah, it's already running. So I've deleted one pod. The replica set has kicked in, has said, oh, hold on a second. You told me 3 pods. I have 2 available. I need to spin up a new one. And it was super fast. So this is what will ensure that my application stays healthy over time. Cool. So I think we have run out of time. So let me just recap what we've done. So we managed to run a Dockerized version of our ASP.NET Core solution, which uses Redis and Mongo locally on our machine, just by configuring the Docker Compose file. And then we managed to spin up a sort of a pipeline, build pipeline, that automatically pushes my code onto Azure Container Registry. And then we've eventually been able to run it as a container workload on a Kubernetes cluster through a release pipeline and integrating it with some of the PaaS services in Azure. I'm leaving you also some of the commands that I've used during the presentation, because I understand that Docker is a bit, could be a bit complex at the beginning, because it heavily uses the command line. And some recaps on Azure. Again, the slides will be available, so don't bother taking pictures. Yeah, I think that's it. If you have any questions, I'm here, and thank you for being with me in this roller coaster today.
That was really, really, really nice.
Thank you.
I appreciated the straightforward approach in this. Are there any questions from the audience? One. Okay, just a sec.
Hi. My question is, how easy it is to configure the environment on an existing image? Talking about system files, network, web server configurations.
So, in terms of, do you mean in a production scenario, like when it's running in a cluster, or?
Not necessarily, in any circumstance. We used a predefined, let's say, Docker Windows
Docker files,
images.
yeah.
Yes. And what if I want to do a configuration on that image? Like I want to configure...
I got you. So configuration is mainly done through the use of environment variables in Docker containers. So basically, when you spin up a container, you set some of the environment variables that your application will have to read in order to function. Now, the interesting thing is that this is probably one of the least known functionalities of ASP.NET Core, because in ASP.NET Core you have the app settings.json. So how do I read from the environment variables instead of the .json file. It's all done automatically by the configuration manager. So if you create an environment variable, which is something like this, for example, connection strings __ Mongo, it automatically gets, it automatically overrides what you have here, connection strings Mongo. So you don't have to change the way you use the app settings. It works when you're locally. When you deploy it in production and perhaps your connection string changes, you can just configure the environment variables and the ASP.NET Core will do the magic for you.